Alright, in this video we're going to finish off this note sheet and look at the Pythagorean theorem to help us find an unknown side of a right triangle before we can actually find the trig ratios. So I'm going to do example 2 and I'm going to ask you to do example 3 within this video before you move on to practice work. Now, example 2 does say find the sine, cosine, and tangent of the indicated angle, and we're just going to do angle A. But if you notice, in order to find trig ratios, I don't have, if this is angle A, then this would be the opposite. This is the hypotenuse always. But I don't have the adjacent side, alright? So in order to find an unknown side length, I have to use the Pythagorean theorem. Hopefully some of you remember what this is. Theorem. Please write this down though. It is a squared plus b squared equals c squared, where a and b represent the length of the legs of the right triangle, and c is the hypotenuse. Alright? Now, in order to determine the legs, we have to identify the right triangle. In this case, the right triangle is here, and the legs connect to the right triangle. So, one of the legs is 6, the other leg is the unknown in this case. And then the hypotenuse is 10. So I'm going to replace my a squared and b squared. And again, the legs are interchangeable, so a could be 6 or b could be 6. It doesn't really matter. But I'm going to make a be 6 because that's what it's labeled as. So it's going to be 6 squared plus my unknown of b squared equals c squared, which is 10, so 10 squared. And to do this math, I have 6 squared is 36. Plus b squared equals 10 squared is 100. Now I'm solving for my unknown variable of b. In order to do that, I have to first subtract 36 from both sides. Cancels out over here. So I'm left with b squared equals 100 minus 36 is 64. And if you remember, in order to get rid of the power of 2, or any power, you take the inverse root of it. In this case, I'm taking the square root to get rid of the power of 2. And I have to do that to both sides. So I get b equals 8. So I have found my unknown side length using the Pythagorean theorem of 8. And now I can go ahead and find the trig ratios. I want the sine of a, the cosine of a, and the tangent of a. The sine of a, remember, is so it's opposite over hypotenuse. The sine of a is right, a in question, opposite is 6. The hypotenuse is 10. And that reduces to 3 over 5 is my final answer there. The cosine of a is adjacent, it's adjacent over hypotenuse. And so the adjacent is down here. That's 8 over the hypotenuse of 10, which reduces to 4 over 5. And then the tangent of a is TOA, or opposite over adjacent. The opposite is 6, the adjacent is 8. 6 over 8 reduces to 3 over 4. So that is how you use the Pythagorean theorem to find an unknown side length before you can find the trig ratios. So I want to ask you to pause the video and try example 3 on your own. If you notice one of the sides is unknown, you have to determine, is that a leg or is that the hypotenuse, and then fill in your a squared plus b squared equals c squared accordingly, solving for the unknown side before you find the trig ratios of angle B. So go ahead and pause the video and try that. At this point, I have found the unknown side of the right triangle, right here, based off the Pythagorean theorem, a squared plus b squared equals c squared. I made 9. If you notice, one of the unknowns that we were trying to find was one of the legs. And so I made that be b. I was trying to solve for b. The hypotenuse was given to us. And so I made a be 9. Again, it didn't matter. You could have made b be 9 and solved for a. It didn't matter. But I made a be 9, c be 15, and I solved for b right there. Hopefully you got 12. And then I found my trig ratios. Sine of b is 4/5, cosine of b is 3/5, and tangent of b is 4/3. If your work doesn't match mine, or if you have any questions, now would be a great time to ask. And thank you for watching. Good luck on your practice.